Welcome. This is part one of a series I'm doing on writing a parser for a compiler. In this video, I'll give a brief overview of a program I'm writing that identifies words and numbers in an input string using a finite state machine. All the code's available on GitHub, which is linked below. Finite is the main class of our program and represents a state in our finite state machine. As our program is reading the input, we'll move between various finite states, and this is what enables us to match a pattern within the input. Except is added to certain finite states to indicate that a particular pattern has been found, such as that of a word or a number. Finally, the scan method will do most of the work, which is reading through the input and then returning an except state if one is found. We'll start our program by defining two accept objects, one for words and one for numbers. Next, we'll define our finite states. We'll have a start state along with a state for words and another state for while we're matching a number. We'll add a fourth state. In this case, that will allow us to have an optional negative sign before numbers. While our program is running, we'll have a set which contains one or more of these states. As we read input characters, we'll transition to a new set of states. This is what enables us to match patterns, continually reading characters and transitioning to new states. Defining the finite states themselves is really only half the solution to our working program. The other half, which will enable us to match patterns, is connecting outputs between the states. There's basically two types of outputs in our program. One that takes a range of characters, and if any characters within that range, transitions to a new state, and also an empty or epsilon output. These types of outputs don't require any character and always transition to a new state. They're extremely useful for, like in our case, optional states such as the negative sign in front of numbers. Okay, with our outputs defined, we're now going to go ahead and create a vector of these outputs within the finite state class. We're not going to use output values because we later want to be able to reference particular outputs. And so we'll go ahead and use a unique pointer. That way the finite class still has ownership of it, but at the same time we're able to get a reference to a particular output later on. Returning to our main function, we can now add outputs between our states. Using the start state, if we identify a letter, we'll instantly move to the word state. Likewise, with the negative sign, we'll move to the sign state. Using the epsilon or empty transitions, we can also make this state optional. When we're in a state, such as the word, and we continue to read a letter, we need to keep transitioning back to that same state while we're continuing to match the pattern. So we'll do that for both the word and our numbers. With our outputs defined, we can now go back to writing our scan method. We'll have two sets of states, the current states, which are active, and a new found set, which we'll get when we have an input character. However, before we can start reading input characters, we'll have to add an additional function called closure. Closure functions allow us to follow all the empty transitions and add that to the current set of states. For these functions, we'll go through all the states, and if we find a new state on an empty transition, we'll add that to a list to check, as we need to also check these new states for more empty transitions. Once that's returned, we'll have a set of all of our new active states, including their empty transitions. Let's review. While our program is running, we have a list of finite states. As we read an input character, based on the output of those states, we transition to a new set. This is how we're able to match patterns. We continually read input characters and transition to new states. When our input character no longer corresponds to any output, we are done matching our pattern. Let's go ahead and write a method that looks through all the outputs for a given state, and if the character is within range of an output, adds the target of that output to a new set. With our move method written, we can now go back to writing our scan. The first thing we must do is identify any epsilon transitions from our start state. Case in point, our current example, we have an optional negative sign with an empty transition. Once that's complete, we can now read our first input character. We'll go through all the outputs, and if the character is within range of an output, we'll add the target of that output to a found set. After doing this, we must now look for empty transitions from the new found set. As long as we're finding any state, we're still matching our pattern. We'll go ahead and consume the character and set our current set to the found one. If we don't find any new states, we're no longer matching our pattern, and we go ahead and break out of the loop. There's still one method left to write. When we are no longer matching any patterns, it is possible that there's still more than one active state. We'll need some way to compare two states to determine which of those states has the lower rank. With our comparison function written, we can now go back and look through all of our final resulting states, determine which state has the lowest rank, and then return that as our accepted match. With our scan method implemented, we can now set up a test case. We'll continue to read through this stream, calling the scan method from our start state. If this scan results in a pattern being matched, then we'll have a pointer to the associated accept returned. Let's go ahead and build and run our program. And you can see the program correctly identifies a word followed by two numbers and then another word. This concludes our example of using a finite state machine to identify words and numbers in an input string. Thanks for watching, and if you want, go ahead and subscribe to be notified of when I post the rest of the videos in this series.